All right. So, last lesson of chapter 1. Looking at perimeter, circumference, area is what we'll be getting into. But before we do that, if we look back at our last one, we talked about distance and midpoint. So let's find the distance between these 2 points to the nearest tenth. So, d equals the square root. So we start by subtracting the x's. Again, it doesn't matter which one you start with, but just try to kind of keep that the same. So if you start with t with x, start with t with the y, and that generally keeps things straight. Although really you can have them flipped wherever the squares take care of all that. So if we start here with x, so we would have 5 minus a negative 4, which would make it a plus 4 squared, plus we are 2 minus a negative 1, which would be plus 1 squared. Well, 5 plus 4 would be 9 squared, plus 2 plus 1 would be 3 squared. So 9 squared would be 81. 3 squared would be 9. So we're looking at the square root of 90. Now, if it said write in simplest radical form, that's where we would do the factor tree and do 9 and 10, which 10 goes to 2 and 5, 9 goes to 3 and 3. So we would write this as 3 square roots of 10. However, it says nearest tenth. So grab a calculator. We can do second square root of 90, and we get, other stuff was hit. So second square root of 90 will leave us there with 9.49, which nearest tenth will make that 9.5. And we'll do the little squiggles. So, moving on to today's lesson. So, if you were in class, which I don't know if you'd have this sheet of graph paper at home, but what I would have you do if we were in class is take out a sheet of graph paper and then you would draw 3 different rectangles. One would have a length of 5 blocks with a width of 2. So think we're 5 long, width of 3. The next one is 8 blocks long by a width of 2, and then the last one will be 4 by 4. So then we'd be able to add all the sides to find the perimeter. Well, we would do 3 plus 5, which would be 8, plus another 3, which would be 11, plus another 5, which would be 16 for the first one. 2 and 8 would be 10, and if we double that to get the rest of the way around, so 2 and 8, 10, double would be 20. Here, 4 of those would be 16. Next, we would find the area of each by counting the blocks. Well, if we counted these up, we'd have 3, 6, 9, 12, 15. 2, 4, 6, 8, 10, 12, 14, 16. And then 4, 8, 12, 16. So we have a couple questions here. First off, rectangles with equal perimeter, do they have the same area? Well, our first and last one had the same perimeter, but they didn't have the same area, so no. And then, do rectangles with the same area have the same perimeter? Well, our same area, different perimeter. So again, no. So what this does is, you gotta think about, just because their outsides may be different, they may still give you the same perimeter or the same area, but it doesn't mean they're, just because one's the same, they're all going to be the same. So here's the 3 main shapes we're going to look at. So looking at squares, rectangles, and circles. So perimeter of a square is just the side times 4. Area is just the side squared. Perimeter for a rectangle is just the base and the height added together and doubled. Area, though, is you multiply the base and height. So circumference With diameter, you just take it times pi. With radius, you got to double it and then take it times pi. So that goes back to there's two radiuses and a diameter. So either way you look at it. So that's where if they give you the radius, double it, then take it times pi. If they give you the diameter, just take it times pi. Now, we'll get into here, just like with distance formula there, you got to pay attention to how they want the answer. If they say leave it in terms of pi, all you got to do is just write the diameter with a pi symbol, or take the radius and double it and then put it with the pi symbol. Or they'll say nearest tenth, nearest hundredth, and then you'll actually multiply it all in. Area then is pi r squared. So same thing, you would just square the radius, put it with pi, and you'd be done if it's leave it in terms of pi. So, your pool is 15 feet wide by 20 foot long. So let's draw that picture. So we're 15 wide, 20 long. It's going to have a 3 foot wide deck surrounding it. So around the outside here, think of it almost like a picture frame. You're going to be 3 foot wide all the way around. Now, you want to build a fence around the deck. How much fencing will you need? Well, we got to look at how long is that outside of that deck actually going to be, and how wide is it? Well, if we're 20 long here, we're also another 3 and another 3, so that really makes it 26 long. And our width then would be 15 plus 3 is 18 plus 3 is actually 21. So that gets us our outer diameter, or outer dimensions, not diameter, sorry, outer dimensions of our pool. So if we want to do a fence around the deck, think distance around is your perimeter. So perimeter of a rectangle would be twice the length plus twice the width. So 2 times 26 would be 52. 2 times 21 would be 42. If we add that together, we get 94 feet. Now, perimeter, the label, it's just a length, so it's just units. Okay. Find the circumference of a circle with a diameter of 12 inches in terms of pi. Then find the circumference to the nearest tenth. So this is what I was talking about. So if it's diameter of 12, circumference is just pi times diameter. So you'd have 12 pi, and we were inches, because again we're distance around. So terms of pi, that's all you got to write. And then it's to the nearest tenth, we'd actually multiply that in. So if we take 12 times pi, we would get 37.699, so we're going to round that to 37.7. So again, it's their distance around, it's just distance, so it's just units, so inches here. So keep that in mind. Here we wanted it first in terms of pi and then to the nearest tenth. Sometimes they may ask for both, and so you're going to need both of those answers. Otherwise, give me whichever one I want. So terms of pi, nearest tenth. So find the perimeter of a rectangle, of a triangle, sorry. Find the perimeter of triangle ABC, where A is at -1, -2, B is at 5, -2, and C is at 5, 6. So this is where that graph paper comes in handy again, that you would have in class. Excuse me. So if I draw a little chart here, a little coordinate plane. So A being at -1, -2. B is going to be at 5, -2. And then C is going to be at 5, 6. So, nice thing about this is this makes it a right triangle. So this is vertical. We're going, and I'll write these out. So -1, -2. Here we would be at 5, -2. And here we're at 5, 6. So from -1 to 5 would be a distance of 6. From -2 up to 6 would be a distance of 8. And then we just got to find our slant side, which we can do with that distance formula. So 5, I'm going to start up there, 5 minus a negative 1 squared, which will make it plus 1. Then y 6 minus a negative 2 squared, which will make it plus 2. So 5 and 1 would be 6 squared, plus 6 and 2 would be 8 squared. So 36 plus 64 would be the square root of 100, which is 10. So that's our last side. So as far as perimeter of a triangle, there really is no special formula. You just got to add the lengths of the sides. So 10 plus 8 is 18, plus another 6. Our perimeter would equal 24, and it don't have it, so we put units. Whatever doesn't have a label, put units. Yeah. Some space here. So you're designing a rectangle banner for the front of the museum. The banner will be 4 foot wide by 7 yards high. How much material will you need? So here we're looking at material, so we're covering a space, so we're looking at area. Now, be careful here. Look at these labels. We're 4 foot and 7 yards. You have to have the same units. So either we convert the 4 into yards or the 7 into feet. Now, for me, 4 foot isn't going to be real nice changing over to yards. So I'm going to change this to feet first. So there's 3 feet in a yard. So this here would equal 21 feet. So area of a rectangle, we're just going to multiply them. So 4 times 21 would give me 84 feet squared. So anytime you're dealing with area, it's always going to be units squared. So feet squared, meters squared, whatever you're dealing with, it's going to be squared. Now, we don't get into volume here, but then if you go to volume, that's where we get cubed. So feet cubed, units cubed, meters cubed, something like that. So the diameter of a circle is 10 inches. Find the area in terms of pi. So area was pi r squared. So in this case, our diameter is 10. So radius then would be half of that, which is 5 inches. So keep that in mind. There's always 2 radiuses for 1 diameter. So double the radius gives you diameter. Cutting the diameter in half gives you the radius. So A would equal pi times 5 squared. Well, if we're going to leave it in terms of pi, we don't have to multiply the pi in. So this would just be 25 pi, and we're inches squared. So again, we're area, so we square the unit. But that's the nice thing about leaving in terms of pi. You just put the pi there, and you're good to go. You don't have to do anything more with it. Now, couple postulates. We have postulate 1.9, which if 2 figures are congruent, then the areas are going to be equal, which makes sense. So if they're the same shape, same size, same everything, their areas should be the same. And then postulate 1.10 saying the area of the region is the sum of the areas of its non-overlapping parts. So what that allows us to do is when we get an irregular shape, so something that may be made up of rectangles, circles, squares, whatever, we can break them up into the parts and find those that we know and then be able to put them all together to get the whole thing. Case in point, this shape right here. So we don't have a shape for, or any equations for this shape. However, we can look at this a couple ways. We can either, and let me draw this out here. So we can either go and make it 3 squares, or we can make it into rectangles. You have a couple different options there. Either way, you'll be able to find the same size here. So notice how we have all these tick marks on the bottom. That means each of these are going to be 2 meters. So like in this case, we're 2 by 2, which makes this 4 centimeters squared. This one here would be 4 centimeters squared. I don't know why I started writing the label. So if this whole thing is 6, notice again we have the tick marks. This here over here would be 6. Well, we're 2 off on both sides. So this is really 4 by 4, which makes this 16 in the middle. So 4 plus 16 plus 4 would give us 24 and centimeters squared. If we did it the rectangular way, so this would be 6. We know these are all the same. And these are 2's. So this one here would be 2 by 2, which makes this 4. Well, this would be 2 and another 2 to make this 4 by 2, which is 8. And then this would be the 6 by 2, which is 12. Well, 12 and 8 is 20 plus 4, 24 centimeters. So it doesn't matter how we break it up. We can just break it up and do whatever shapes that we have equations for. And then we can find those out and put them together and get, we'll add them up, total them up, and we'll get our answer. So that's it for this lesson. Let me know if you have any questions, comments, concerns. You can always pan me, email me, send me a message on Google Classroom. Keep in mind, you can always pause the video if you need time to write stuff down. You can always rewind it and watch it again if you missed something. Otherwise, we'll talk to you later.